This is an explanation of how to make the Lewis dot diagram for propane, or tricarbon octahydride. These use purely covalent bonds and are made up of 8 hydrogens and 3 carbons, as seen from tricarbon and octahydride. This molecule is made up of a chain of carbons with hydrogens surrounding it, so we start off with 3 carbons in the middle. The highlighter represents a bond between 2 electrons. The electrons within these bonds are shared between the carbons around them, creating a covalent bond between them. The carbons on the outer ends all have 5 electrons each, and the inner one has 6, so the hydrogens can fit in snugly between these openings. As you can see, each hydrogen fits into the openings of the carbon. 3 on the end, completing the 5 to make 8 valence electrons for the carbon, 2 in the middle to complete the 6 to create 8, and 3 on the other end, the same as the first, to create 8. And each hydrogen is full in itself because its original ring only needs 2. So with each line representing a covalent bond, this is what the Lewis dot structure would look like. So next we have the Lewis dot diagram for a sulfite molecule, and it is written out with this. 1 sulfur, 3 oxygens, and a -2 charge. First we start off with the atoms we're going to use. 1 sulfur with 6 valence electrons, and 3 oxygen, also with 6 valence electrons. We start off with a sulfur in the middle with 6 valence electrons in its outer ring. Each oxygen atom can fit into the sulfur like this, with 1 oxygen being completely filled, while 2 having 2 open spaces. These open spaces mean that the oxygen only has 7 electrons in its valence ring, and it takes 1 electron from the atmosphere. So in the end, we get a dot diagram that looks like this. The sulfur in the middle with 3 oxygens attached, and a -2 charge, representing the 2 electrons that are not present in the valence rings.